Evening, Professor. This is my personal timetable, and here I'm going to explain what is my current this week plan, and also I want to discuss about the new methods, like what type of method we have to use for our research, like coating as well as the fabrication, in terms of getting the stable value. So here we go. So first of all, I just want to tell the what kind of chip we are using. First is DIDC, it's a D5 chip, and second one is the P6. So these two chips we are using for the biosensor research. So as as per this chip, we have to use the different kind of methods of coating. So first one I just proposed this one for our research. Why? What is the basic, like what is the main positive aspects for this method, for the especially for the coating? Because if I compare with the three different kind of coating method, like spin coating, spray coating, normally people call inkjet coating, and also deposition electrochemical deposition method. Like, this is the spin coating is basically simple process. We just simply drop down onto the surface, and the spray also the same thing, but its deposition, electrochemical deposition, is like slightly complicated, but there is no as such more complicated, because we have the common vessel like this, and we just put into the solution. What any kind of solution is basically depend on the viscosity of the liquid. Like, we have in our case we have the graphene oxide, and we want to immobilize the graphene oxide in our chip. So before to start this experiment, like deposition or like process, so first of all we have to make our chip in terms into the hydrophilic from the hydrophobic. So this method will be done by the piranha cleaning. So before to go to use that machine, we have to uh, uh, clean with the piranha solution, as we have already mechanism. So after this, our surface is being hydrophilic, as well as the most suitable surface for the coating. So we just put into the solution like graphene oxide, and then we just dip into the solution like the this part up to this part, and then we have the different kind in the electrochemical method. Basically it's a three different kind of electrode just joined together in a machine called electrochemical machine, like EVM, like impedance EIS system machine. So is the machine itself using it with the help of current, or like in the terms of specific voltage, and manually frequency range we have to set up for this. So basically this is having the reference electrode, is having the counter electrode, is having the working electrode. Working electrode is basically our chip, either D5 or P6, and reference is the AgCl electrode, and auxiliary is counter is a by default platinum electrode. So basically, it's the three different kind of electrode dip into the solution with the cover of the one vessel, a small beaker, and then we have to, start with the specific parameters. For example, as per my understanding, also I discussed with my PhD colleague. So they said, like, um, previously we use SiC wafers to immobilize the graphene oxide solution. So we just use the 1 ampere current, and the voltage is like less than 10 volt, and scanning rate, like how much scan rate we have to use, like, so we normally use the 1 millivolt per second scan rate. So this is the basic process that we have to use. And why is the basically what is the positive aspect of this deposition method? The basically there is no bubbles onto the surface, there is no dust onto the surface. Otherwise, spin coating, at the time of spin coating, rarely chances of the having the bubble onto the surface. Rarely. I'm not saying normally. I'm saying rarely, but dusting is the main priority to neglect this part. So because of dusting, the layer is not uniformly deposited onto the surface. And so basically, a parameter is already known is a voltage or temperature as well. And there is basically so uniformity is very good in this electrodeposition case. It's a reproducible and good uniformity, best among this the three methods. And it's a suitable application is in the case of transfer patterns that run in and across cavities in this case. And I'm pretty much sure that this method is more feasible and more good for our research. That's why I'm just focusing only this method, because I already tried spin coating. I already tried dip coating, but is the last method that I have option, or like you say, better than these two previous coating methods. So I'm pretty much sure is electrodeposition method is much more efficient and positive um, factor for the coating method. So this is the basic mechanism and that we have to follow. And as I already told, before to dip into the solution, we have to use piranha cleaning to make our surface hydrophilic from hydrophobic. So I just normally I have the uh, you know um, comparison, because before to use I just want to know more about this, how is working this machine and what is the basic parameter itself into the machine. So I just make a comparison because it's my it's my uh, um, knowledge about, like, we used before the EVM stat. It's basically it's EVM stat machine, and its company is EVM Soft. So basically, the current compliances as compared to this machine is very low, but is okay because we have to use in between this current range. So it's okay, and the voltage is almost same, 10 voltage to plus minus 10 voltage, and the minimum maximum applied voltage is basically 10 volt. And in this case, this machine is only having the one channel, but in this case this machine having the five channel, as you see in this image, like 1 2 3 4 5. So five channels connected in the one machine. So there is no any changes in between these two machine, either having one channel, either having five channel, either having eight channel. It depends on the system, it depends on the machine performance. So if you having the more channels, the performance will be better, or like you will get the deposition rate, or like deposition timing is much higher, or much getting the deposition will be done in the small time period. So that's why is the positive aspect in this machine. So because itself this machine having the five channel, and this machine only having the one channel. These I used before, but in this week we plan for booking this machine and to check with our chip, and hopefully we will get the positive response, as well as the deposition rate or the value of the capacitance is much more stable than the spin coating and the dip coating, either or any kind of coating methods. And simultaneously I am also uh, concentrate on to the after the electrodeposition of the graphene or either uh, APTS onto the chip. So, excuse me, before to explain this, I just want to explain here one more thing. We have the two different kind of chip, T5 and P6. So we just use two different kind of solution. First is graphene oxide, and the second one is APTS, and the third one is APTS with graphene oxide. So we use here three different kind of solution, and we run with the two different kind of chip, D5 and P6. So each each solution having the five different kind of chip. Like for example, if we use graphene oxide solution, so we use 5 D5 chip, 5 P6 chip, and for APTS 5 D5 and 5 P6. And for mixing like graphene oxide and the APTS, we use 5 D5 and 5 P6. It's like total 15 D5 chip and 15 P6 chip for this electrodeposition case. So here we go like the layer by layer method after the electrodeposition. So if we have the graphene oxide electrodeposition onto the surface, then we just use APTES. Either we have the graphene oxide onto the surface, then we use APTS, okay, and then we have the amine group of clear ions, and then we use EDC NHS with antibody. Here I have seen the different method, like we use mixture of the EDC NHS and the antibody together, and then we immobilize onto the surface. So in this method I have learned that if we use EDC NHS and antibody together onto the surface and incubate 1 hour for the 37 degrees Celsius. So this maybe is like fruitful, because this paper is already published in the Nature America inclusive. So this method is already proved. So that's why my main focus is to deal with that. And then after this, we use BSA for the blocking as a blocking method. So this thing my main focus is to this. And then after the BSA, we use antigen in a different kind of concentration for 1 hour at room temperature. No need to, no need to wait for the whole day or something. So we just uh, 1 hour or 2 hour for each case, like antibody and antigen. Hopefully then we will get the positive response in terms of capacitance value. This is the second phase after the electrodeposition method. And then again in the next I'm going to explain the another method after the electrodeposition of the graphene, either APTS or either mixture of the graphene and APTS. This one. So if we have the deposition of the graphene or something, and then we deal with the EDC and antibody together, as I already told, that if we mix together EDC and antibody, then we uh, have the like wait for 1 hour and 37 degrees Celsius, and then afterward we use BSA, because this is the second method I have seen that the EDC or antibodies mixed together and then we use the antigen or like BSA. So if we mix EDC and antibody, it might be getting the positive response either if we use the separately layer by layer, because we already um, proven that we use layer by layer, like first graphene and then EDC and then antibody and then antigen. It's like four different kind of steps we have to follow. But in this case, we have seen that I have seen that EDC and antibody mixed together and make the solution for like together, and then wait for 15 minutes and 80 degrees Celsius, 37 degrees Celsius, and then we put onto the surface, wait for 1 hour at 37 degrees Celsius, and then after BSA for 30 minutes and 37 Celsius. 37 is basically a room temperature. There is no specific mention here for the room temperature. They mention only the specific temperature. So we have to maintain this temperature in the incubator. So we have to set this temperature, and wait for the specific time period in each step. So this is the another method after the deposition method. So it's basically having the gold coated SPR chip. Is SPR chip is basically is a screen printed chip. So and then, as I already told in the previously, we have seen that EDC and mixed together with the antibody. But in this case, antibody is mixed with APTS. uh, APTS, yes, APTS. Someone is mixing with the APTS and someone is mixing with the EDC, because EDC and APTS are the cross-linkers. So if we mix together with the antibody and then immobilize onto the surface, and then we use BSA, it's a weight for volume ratio, and wait for 3 minutes. Why here? Because 3 minutes, because already gold coated SPR chip. So that's why it doesn't take so much time for the binding. So, but in our case, 1 hour or 2 hour for this case. So 30 minutes for our case is like 2 hour, and then for BSA washing and wait for 30 minutes, and then HFA is a kind of antigen. So it's a human futin A. So it's antigen. Following the we use the antigen after the BSA washing. So in all the three methods, layer by layer methods, after the deposition of these things, we have to we conclude I conclude that we have to mix together with the antibody and antibody and cross linker, either EDC or either APTS, and mix together, and then we immobilize onto the surface. This is my main this is the next step. Like if we have the deposited chip, so then we found that that the immobilization step is much more convenient, or like the stable process. So this is my next step to follow the for our research. And then another method is like we it's layer by layer. If we have the deposited chip, graphene oxide chip onto the D5 or P6 chip. So then afterwards we have to, it's a serial process like layer by layer. So if you see here, APTS, and then after APTS, like you just use this 1% APTS, and then 1% APTS after APTS mobilization is mixed with the glutaldehyde and antibody. Here is the different method to antibody with glutaldehyde solution. In my previous paper, it's applied biomaterial paper. We already used this solution, but not mixed with the antibody. So from now onwards, we just mixed together with the 0.1% glutaldehyde with the antibody, and then immobilize onto the surface, and then wash with the BSA, and then we fix with the antigen. So this process, so here I have found that four different kind of coating method we use in our research. So but first of all, before to apply these kind of method, we have to focus on the coating of the graphene and the APTS, and the graphene with graphene APTS mixture together onto the surface. So I talked with the Ryun Sang called the responsible person of that machine. So today we call that, and in this week or like next week, we we will go to there and apply the electrodeposition method, and I'm pretty much sure that we will get the positive response after the deposition. And we have to follow this kind of step. And simultaneously, I'm also looking for the new method also, like which one is good for our research, and I'm 100% sure we will get the positive response. And I'm also simultaneously working the research and research. So like to searching, and we get the positive things. So this is my sir PPT, and this is my plan for this week. Either if we have the bookings for the electrochemical method in this week, so I will start this method after this. Otherwise, if we don't have the bookings in this week, so hopefully next week we will go for the deposition method appliance. So I just skipped this one because I don't think so. We have to repeat this one, and then it's not. Obviously, it's a research for finding a new method. And thank you, sir.